fools! It was a cold and silent night. The weather was freezing cold. A group of monkeys were on a tree. They were clinging to its branches. One of the monkeys said, "I wish we could find some fire. It will help us to keep warm." Suddenly they noticed a flock of fireflies. One of the young monkeys thought it was fire. He caught a firefly. He put it under a dry leaf and started blowing at it. Some other monkeys also joined in his efforts. In the meanwhile, a sparrow came flying to its nest, which was on the same tree the monkeys were sitting on. She noticed what they were doing. The sparrow laughed. She said, "Hey silly monkeys, that is a firefly, not real fire. I think all of you should take shelter in a cave." The monkeys did not listen to the sparrow. They continued to blow at the poor firefly. After some time, the monkeys became very tired. Now they realized that what the sparrow had said was correct. They set free the firefly and moved to a nearby cave. The secret of the fireflies. Scientists have long known what causes the yellow, orange, or sometimes even blue flickers of light that fly around our backyard on summer evenings. They are the fireflies, also known as lightning bugs, and they have fascinated scientists and lay people alike for ages. About 2,000 species of fireflies exist today, and they mostly live in warm environments. These insects are actually beetles, and belong to the family Lampyridae. What causes those flickers? Scientists have known the basics all along: oxygen, magnesium, calcium, and luciferin, a chemical that is naturally occurring that causes the bioluminescence from the firefly's abdomen. However, the actual chemical reactions that cause the firefly's light have been a mystery. Bruce Branchini at Connecticut College, Yale University, and his colleagues seem to have solved the mystery. The findings of their study were recently published in the Journal of the American Chemical Society, and it sheds light on the chemistry that lies behind the bioluminescence. Branchini's studies showed that the oxygen responsible for the firefly's glow is in a special form, a superoxide anion. It is a form of molecular oxygen containing an extra electron. This enables the oxygen to react with luciferin, to produce the glow. Stephen Miller, at the University of Massachusetts Medical School, a chemical biologist, said that this phenomenon is important as an area of research because luciferin has potential uses in the medical field. For example, a team of scientists including Miller used luciferin to detect specific enzymes in the brains of living rats, which could lead to identifying a method of looking at the hidden mysteries of the human brain. Who knew that the humble firefly had so much chemistry in it? And so much promise for science.